Which brings us to the final part of the lecture. Tools for assessing inductive force, and particularly assessing using conditional probabilities for when assessing inductive force, which is a difficult part of the lectures. So difficult I even made a typo in the header for this section. And it's difficult to use those formulas because it becomes more abstract. So I want to give you some other tools that might make it more intuitive for calculating those probabilities. All right. So if you encounter a book which is called Aid to be Great, written by Richard St. Johns, that's just one example of multiple examples I could give you about self-help books, right? And those self-help books supposedly show you, describe usually the lives of great people, right? So here's Bill Gates and here's Steve Jobs, and here's what all these great people share and in different characteristics they share. So what the title says, it only implies that here are just great people and they share all these 8 traits. So if you're a great person, you have those 8 traits. The implication of the book goes further than that, or it wouldn't sell any copies, right? Most people seeing this think, well, I gotta read that book. I gotta make sure I have those traits so I can make sure I become great as well. Which is indeed inversing a probability, or inversing those terms, right? What the book says is that the probability that you have those characteristics, given that you're great, is 100%, right? All great people have these traits. And what you want to know is what is the probability that you're going to be great, given that you have those 8 traits. So you read the book, you make sure you have those 8 traits, and then you want to know what the probability is that you are going to be great. And that's more difficult to assess because that's the reverse. That's not 100%. It's probably a different percentage, but we need more information for that. So there's a couple of ways of dealing with these type of tasks, right? So if I give you information about does the probability of being great, given that you have those traits, equal the probability of having those traits given that you're great, the inverse terms, does that bear the same probability value? Then there's an intuitive response I want you to have. And that's the Sharknado intuition. It has to do with the great immortal movie Sharknado. And in the movie Sharknado, basically what happens is that it's a watery screen behind me. How appropriate. The sharks in Sharknado actually don't need water to swim in, by the way, but that's beside the point. So what happens in Sharknado is that a bunch of sharks get picked up by a hurricane, and the hurricane deposits the sharks at random locations in LA, and so people get eaten by flying sharks, right? I think you would agree with me that this is an unlikely event, right? It happens in the movie, but you never heard of it, so that's highly unlikely to happen. So let's say you die. You've died, and you end up at the gates of heaven, and Peter asks you, so, hi, how are you doing? You're dead. Sorry. But given that you died, what is the probability that you've been eaten by a flying shark? So we're asking a conditional probability. What is the chance that you've been eaten by a flying shark, given that you know you've died? Not very high, right? I wouldn't judge it to be very high, because I never heard of it before, right? So you're there at the gates of heaven, and you're thinking, well, I never heard before in my life that somebody got eaten by a flying shark. So, Peter, probably the probability of being eaten by a flying shark, given that I've died, is very low. All right. You got that in your head, that probability? I mean, it's your own probability. We're now going to show why you can't just reverse that probability. So usually this example would have sound, but that would take time switching to the screen share. I'm going to skip that part. So if you want to hear the sound from the movie Sharknado, it doesn't improve things. Take it from me. So this happens, right? So you're standing on the street with your chainsaw, and suddenly a shark comes falling out of the sky. All right, Perhaps you got a little bit of that sound through my own microphone. Made it perhaps more convincing. So this happened, right? You were standing there in the street and you jumped into the shark with your chainsaw. And then somebody asked you can just hear it to the muffled sound of the stomach of the shark. And they ask you, what is the probability that you'll die given that you've been eaten by a flying shark? That would be a different number, right? Given that you've just been eaten by a flying shark, what's the probability that you die? Well, I would say it's likely that you die, given that you've just been eaten by a shark, flying or not. At the very least, that probability that you'll give as an answer for this question will be higher than the one you've answered in the first question, right? That gives you an intuition. That gives you the intuition that the probability of being eaten by a flying shark, given that you died, is not the same as the inverse. The probability of dying given that you've been eaten by a flying shark. So you have the intuition, the Sharknado intuition, that the probability of A given B doesn't necessarily equal the probability of B given A. That's the first step, because now you're on the lookout. So the next time I give you a conditional probability task, so something in which you have to inverse a conditional probability. So what is the probability that you'll be great given that you have these 8 characteristics, even though the only thing we know from this book is that all people that are successful, so the chance of having these probabilities given that you're successful is very high. You need to inverse that probability, and you need to be on the lookout. You need to have that Sharknado intuition. You need to think, no, I can't just go around inversing those conditional probabilities. I need some other stuff. Is it provided? No. If not, then you should say it's invalid, the argument, or you should say I can't properly calculate that conditional probability. If it is provided that information, you can go about calculating the actual probability that applies. So we're going to try that out. Given is the following. All successful people have these 8 traits listed in the book. 20% of non-successful people also have those traits. And most people aren't successful. I'm sorry to break it to you guys. Usually the criteria we apply to saying that somebody is successful are a bit strict, right? So it's lonely at the top. So we're just assuming that not a lot of people are successful, right? So 5% of people are successful, 95% of people are not. You read the book and you find out that you have those traits. So what can we conclude on the basis of that? Is it certain that you'll be successful? Is it highly likely that you'll be successful? Is it somewhat likely that you'll be successful? Is it somewhat unlikely that you'll be successful? Is it highly unlikely that you'll be successful? Or is it certain that you'll be unsuccessful? So you need to know what's asked of you, right? I think you can recognize that. And that's the first step. So I'm getting back to the answer options in a bit, but I just want to help you along in what you should be calculating when I ask you this. So when I ask you how likely is it that you're going to be successful, I'm asking you what is the probability of success given that you have these traits, right? That's the thing that you put in at as the first symbol in the formula for calculating conditional probabilities. Then you need to look out in the problem description what other stuff you need, right? So you need the inverse. So that would be the probability of having those traits given that you're successful. Well, you should have recognized it, right? Because the problem says, well, all successful people have these traits. So you know that probability and you can fill it in here. You also know the base rate, right? So you know that most people are unsuccessful. So the probability of success is very low, just 5%, right? And you also need to know the stuff below the break, right? So you need to know this we already filled in, right? So that's the stuff printed in green. And we also need to know the probability of having those traits given that you're not successful, which is the 20%. So this is the first step. If I ask you to calculate conditional probabilities, what I think most people get wrong, well, it's 2 things. First of all, people neglect the base rate. So they neglect that they need the base rate in calculating conditional probabilities. And we try to solve that by creating that Sharknado hunch, that Sharknado intuition. So you know I need these 3 things before I can calculate that conditional probability. So you know that for certain. The second step where people could make an error is in properly recognizing what probabilities go where in the formula. which is what I tried to help out with using these colors. So back to the problem. Given the following, how likely is it that you'll be successful, given that you have those the 8 traits? I'm seeing a lot of E's here, and let's just check what the answer is. There's 2 ways of coming to that answer. The first one is plugging all the relevant probabilities in the formula. So you always need to recognize the relevant probabilities, and you need to plug them in. You can plug them into the formula, or you could do something else, which is fill in a frequency tree, which is just another word for a tree diagram. And in all conditional probability tasks I will give you in this course, you could use this tool if this would make it more intuitive for you. I mean, you still need to recognize the base rate, the sensitivity, and the specificity of the information. That you needed to do that as well when using the actual probabilities in the formula. But if you're able to recognize them, you can fill in all the boxes in this frequency tree. What we do is we start with an imaginary population. Let's say we start with 1,000 people, and then we apply the different probabilities. We apply the base rate first. So let's say that we start with 1,000 people. Did I start with 1,000 people? Let's just check that out. 100 people. We start with 100 people. It doesn't matter whether you start with 100 or 1,000, but pick a number that you can easily make the calculations on. Let's say you start with 100 people. That's the whole population. And you can apply the base rate to that population. You know, without making any further assumptions, that just 5 people out of those 100 people will be successful, right? That's what the base rate means. And you apply that, you plug that into the frequency tree boxes. So you know that when applying the base rate and you have a population of 100 people, you know that 5 out of those 100 people will be successful. And, yeah. You see what happened? I think I started out with 1,000 people in the past before, so that number, I've fudged that up. Sorry. And what you then can do is apply the sensitivity to success, the successful people, right? Because you know, out of all people, 5% is going to be successful, and out of that 5%, all people will have those traits, right? So 5 out of those 5 people will have the traits, and 95 people out of those 100 will not be successful. And then you can apply the rest of the information, right? So you know that 20% of those 95 people will also have the 8 traits, right? So then we can answer the question, if we apply the information properly, as follows. So given that you have those 8 traits, what is the probability that you'll be successful is the same as asking, given that you know that you're either in this box or you're in this box, you're either in one or the other, you don't know which one, what are the odds that you are in this box? Which is the same as saying, well, that's a chance of 5 divided by 19 plus 5. So how many cases out of the total cases in which you have those 8 traits do you actually have, are you actually successful? That's in 5 cases out of the 5 plus 19, 24 cases that you have the 8 traits, which gives you the actual probability of you being successful given that you have those 8 traits. That's right, Daphne. As you can see in the bottom of the, hopefully you can see in the bottom of the slides as well. Perhaps this should help. So what I've tried to give you is 2 different tools for assessing conditional probability or calculating conditional probability. The first step is the Sharknado hunch, right? Recognizing that you need 3 different things for calculating a conditional probability, of which the base rate is a part. And the second step is recognizing the relevant probabilities from the problem I give you and recognizing whether all information is present or not. If it's not all there, it's not possible to calculate that conditional probability. So you will have to conclude, if we apply that to an actual argument, that the argument isn't valid and it is not forceful. If the information is there, you can use it to check what the probability is of the conclusion, given that the premises are true, right? You can calculate that actual conditional probability. You can find out whether it is indeed more probable than not, given the premises. You can do that either by using the formula, so plugging in the numbers in the relevant spot in the formula, if that works best for you, or you can do it using the frequency tree, which uses actual numbers, which most people find more useful or intuitive to reason with. So it's intuitive for you to see, well, oh, here I have all the successful people, so I need to apply that conditional probability to that part of the whole population, which gives me in this case 5 people out of 5. Hopefully what would make it again somewhat intuitive is using those boxes again, right? So you start out with the whole population. This is what we actually do in the frequency tree, and you indicate that of all those people, a small part will be successful and a lot of people won't be successful. And hopefully the difference between the green box and the red box makes it more intuitive that the impact of that base rate is very high on that eventual conditional probability. So that's why we can't neglect it. That's why we need to use it in calculating conditional probabilities. So we know that on the basis of the base rate, not a lot of people are successful, most are unsuccessful, and we know that of all the successful people, all have those A traits. So the A traits completely overlaps with the successful part of the box. And we know that given that you're unsuccessful, there's still 20% chance that you have those A traits and an 80% chance that you won't have those A traits. So if we then plug these values in the calculation that we make, what the question then becomes is, given that I know that you have those A traits, so just 2 boxes remain, right? So we're either here or we're here, but we don't know where we are, whether we're in this box or in this box. What is the probability, given that you're in either of these boxes, in one or the other of the boxes, what is then the probability that you're in this one? Well, that's what you can calculate, right? So you take that one and you calculate that as a proportion of the total number of cases that you have those A traits. That's what we actually just did. That's what we did with the frequency tree, or what you did with the formula. You apply the base rate, and then you apply the sensitivity and the specificity to see in which number of cases people have those A traits, and then you can calculate in what percentage of situations in which people have those A traits are they actually successful. And that's how you calculate conditional probability. Rounding things up, we started out this week with talking about deductive validity, right? And we talked about what types of deductive arguments there are and how you can assess deductive validity, which is a property of the connection between the premises and the conclusion. Then this week this lecture we talked about that connection between premises and the conclusion, but we didn't talk about a relationship of logical necessity, but we talked about a relationship of probability. Is the conclusion, or how likely is the conclusion to be true given that the premises are true? And we didn't look at logic in this lecture, but we looked at probability theory for helping us out in figuring out how likely the conclusion is to be true, or how reasonable it is to believe the conclusion to be true, or what our degree of reasonable beliefs should be about the truth of the conclusion given the premises, to use the full terms from the book. In both cases, we talked about an example, and that's the final thing I want to talk to you about, is the frog example, right? Because we started the lecture and I said, well, we've analyzed this as a deductive argument. As a deductive argument, it's invalid. But perhaps an inductive argument was intended, right? Perhaps they didn't want to say, if you experience positive emotions, then for sure you have this type of brain activity, left lateral dominance, or LLD. So LLD, therefore you have positive emotion, which is a fallacy, right? You can't go from Q to P that way, given that if P then Q. But perhaps the authors intended an inductive argument. And given the tools that we discussed in this lecture, you should be able to assess that argument as given here. You should be able to see that as it's given here, this argument, it's not valid, right? You should have that Sharknado hunch, right? Again, because you should recognize that given is a certain probability, and what we need to know for assessing how likely the conclusion is given the premises is the inverse of the probability that is given, right? So we need to be inversing probabilities, and for that, for us to do that, we need more information. We need not only know what the probability is of left lateral dominance given that we have a certain emotional experience, we also need to know what the probability is of having that same type of brain activity when having a different experience or a different psychological process is taking place. So again, we need to be able to think about all the 3 probabilities that we need for inversion conditional probabilities, right? So if we put it in a frequency tree, that would look like this. And this is just intuitive, right? They don't provide actual probability numbers in scientific publications this way. But what you as an intuitive critical thinker or a trained critical thinker need to be on the lookout when checking out these type of scientific publication is that when somebody says to you, well, I know that when I'm experiencing such and such, I'm from positive emotions, this type of brain activity is highly likely. What you should immediately think is, well, what about the inverse? Is it also likely to happen when you experience a different psychological process, right? Or you could break it down in your in the tree diagram that we used. So given our all relevant EEG investigations, just part of that will be an investigation which involves positive effect, and the rest will involve something else, another psychological process than positive effect. And in some percentage, probably a very high percentage of those involving positive effect, you will see that type of brain activity, left lateral dominance. But it will also be the case that in a percentage, perhaps a small percentage, in a large number of investigations into something else than positive effect, you will also find the same type of brain activity. And for inverting that probability, you need to be on the lookout for both. Because what you want to know is not just how probable is it that I experience left lateral dominance. No, you want to know how probable is it, given that I'm either in this box or in that box, that I'm also in this box. How probable is it that somebody's experiencing positive effect, given that they show this type of brain activity? As you know, as I've explained to you ad nauseum, perhaps I'm sorry for that, but I just wanted to point out why it's relevant, all the stuff that we're doing, is that you need to take 5 steps this month in trying to learn how to assess arguments. And we've looked at the first step, developing a critical disposition, and we looked at the 4th step again today when we checked what inductive force is, we checked what inductive inferences are, and we checked what role probability plays in assessing the force of inductive arguments. And we specifically looked at conditional probabilities, and I tried to warn you away from committing the base rate error by giving you a silly example from Sharknado, but perhaps that made it stick around in your head. And I've given you a tool using a frequency tree for calculating conditional probabilities yourself, so you can use them in assessing inductive force. All right, that's it for today. I'm taking your suggestions to heart, by the way. The setup for asking questions during the break and after the lecture. If it is a specific question, if it's a general question directly related to what I'm explaining at that moment, feel free to interrupt me. Or feel free to interrupt me in any way. If I think it to be a more specific question, then we can always relegate it to the break after that. Stick around if you have more questions. And if not, I'll see you next week on Friday. The next 2 lectures are both about statistics, both on Tuesday and on Thursday. You're going to get a lecture from Sharon on statistics.